Welcome to Circuit 5B, where we will be adding our second gear motor and making a remote-controlled robot. For this circuit, we'll again break out our trusty dual lock and use it to connect our motors to the bottom of the base plate. We'll attach them on the side with the breadboard, with the silver part pointing towards the side with the IoT red board. Next, we'll connect our wheels by sliding them onto the outside white plastic shaft of our motors. Finally, we'll connect our binder clip to the opposite side of our base plate, making it so we have less friction from our robot dragging our base plate. In this circuit, we'll make our robot move in different directions for different amounts of time by sending it different string commands. String variables hold words that are made up of multiple characters. In our case, we'll deliver command strings like F10 to drive forward for 10 units. However, our function for controlling the robot will expect to receive the distance to travel as an integer input. So we need to convert the second part of our command string into an integer. To do this, we can use the split Python function that will convert our string into a list of strings based on where spaces were in the original string. So for example, the command F10 will be split into a list with elements F and 10. So we'll interpret the first element of our list as the direction to go, and the second as the distance to drive. Since our function wants this distance as an integer, we will pass it to the int function, which will convert it from a string to an integer. That's about it for theory for Circuit 5B. Now let's build the thing. The hookups for this circuit will be pretty simple, considering we are keeping all from the last circuit. All we have to do is connect our second motor's leads up to BO1 and BO2 so that it can be driven in a similar way as the first. Now let's run some code. Our first cell will set up our pins for driving our motors and reading the switch. The next cell will set up some constants. Feel free to mess with these constants to tune your robot so that the numbers in your drive commands correspond to a unit like inches or centimeters. For example, we can change the drive time variable until we see that the command F25 makes our robot drive forward 25 inches. The next three cells will set up our functions for spinning the motors. Finally, we can send a string command to our drive function to control our robot's motion. By altering the string sent to the drive function, we can remote control our robot and send it commands one by one from this cell. If you'd like, you can also run the last cell, which will run every command in the commands list and can be used to make your robot act out a predefined set of moves. That's all for Circuit 5B. I hope you're starting to see just how fun robotics can be. I think it's about time we took our robot off the leash, which is exactly what we'll do in our next circuit, where we learn about autonomous vehicles.